Now, now I call upon our senior consultant, Dr. V.V. Nori, for his presentation, the tribute to the legacy of engineer Shirish Patel. Dr. V.V. Nori, the chairman, Messrs. Shirish Patel and Associate Consultants, Private Limited, Mumbai. He has over 6 decades of experience in structural design. He has designed a variety of structures, buildings, factories, hotels, metro stations, bridges, etc., in different materials like concrete, steel, composite, and precast concrete. Many innovative and outstanding structures designed by SPACPL under the leadership of Dr. Nuri won national and international awards. He has shared his knowledge through technical presentations and technical papers during conferences. He is a very well known and well respected personality in the field of structural engineering. Let us welcome him to know more about the outstanding work of SPACPL. Please.
First of all, big thanks to ISSC for making all the arrangements here and inviting me to make a presentation. All the previous speakers have made task much easier, so I will not repeat what has been said. I'm especially happy that Surakshana was here to bring out certain aspects of Shirish which many people did not know. Okay.
Next slide.
Okay. Oh, okay. Look, huh? Yeah, okay. I think I'll use the keyboard. Okay.
Next.
Yeah, okay.
Down button.
Yeah, okay. Well, this is what I would say is remembrance and gratitude. When I joined Shirish Patel in 1965, soon after the flyover was built, and I joined him as a design engineer, and the United India building where we had our office, I was simply amazed at the orderliness of the office. Everything is very orderly in the sense that, he has worked in France, so everything has to come in box files of A4 size. And everything was designed to fit in its place, and when we finished our work, we had to fold our drawings and keep it back neatly. Absolutely, I think it was fastidious for neatness and presentation. And then I was amazed that the things that he had done, whatever Shirish did, has to be aesthetic, has to be very useful, has to be economical, and has to last. It's amazing. This is, of course, in our new office in NM Road, and you can see the last of the drafting tables. Now, of course, it's replaced by AutoCAD. Oh, sorry. Well, see, when I entered the office, this is what I saw of some of the pictures. This is the Chinchwad factory. The architect was Pravina Mehta. Look at the freestanding staircase and look at the freestanding spiral handrail. Shirish would say, why not? That was him. This is a hotel in Juhu, 1965. Pilu Modi was the architect. This structure is in timber, and if you look at the drawings even today, you still have them, it's a good lesson in detailing of connections. And he went much beyond that. There is a mezzanine floor, which I am told is for the permit room, and that was suspended from the roof. So, for Shirish and for all of us, now we learned that small assignments are as important as bigger assignments. Well, Kemp's Corner, I won't repeat what has been said. He was concerned both about the cost and time of completion, because at that time apparently what happened was the traditional bearings would take several months to arrive, and there was no time to be lost. So this was the first application of concrete hinges, and these were cast at site and very carefully vibrated, and they're still there. I think, most importantly, this bridge this is one of those few flyovers which never had to be repaired. And most importantly, the flyover was load tested and completed in time. The costs had gone up, but still below the second lowest. Costs had gone up for various reasons, as I told you, but it was completed in time. And an architect also, Charles Correa, was involved. If you see the flyover, it's like a boat, something like that. So he made it a point to involve architects, especially when you are designing structures where there is no architecture. What are the objectives of SPA? This is what emphasize. Achievement of excellence. It includes structural, architectural, constructional, maintenance aspect, and client satisfaction. And this is very important. But he also said, in case of conflict between client satisfaction and social obligations, the latter will prevail. I'll just give you an example what he meant. I didn't quite understand at the time. This NCPA apartments, which was built on a land which was meant actually for promoting arts, performing arts. But for whatever reasons, they decided to build a multi-storied building, and the architects and the owner approached us. And I was quite happy to do that building because I knew the architects very well and so on. And Shirish called me, Vasudev, it doesn't matter, that you're a designer, but you're doing something, you're giving the property meant for some other purpose. And that is not correct. They can do anything, they can raise funds for promoting national architecture, but not this. So our strategy is to provide good library facilities, good computer facilities, encourage engineers to read and think independently, encourage engineers to visit sites, meet with the clients, contractors, and total participation, and engage transparency. Whatever we did had to be transparent, had to be no oral instructions, there had to be written instructions. Our relationship with the client is built on mutual trust. Small assignments are as important as big assignments. Uniformity in the fee structure is very important, and our clients may be owner, contractor, or architect. It doesn't really matter, but the quality of our professional services remain the same irrespective of who appointed us. I am saying this because there are many people later on we came to know, they design for a contractor, their designs are different from what they give to the client. This is not acceptable. We have to stand by the quality of a professional service. Well, this is one of the first buildings I designed with Shirish. I don't want to go into great details. I can tell you, we are far, far ahead of time. I won't go into the various provisions like more cover and things like that. Much beyond what IS code specified. We also use a statistical evaluation of cube strengths for the first time, not just taking 4 cubes and forgetting about it. And there are so many things where whatever we have said here, it came in the IS 456 after some 14 years. So see, Shirish was always ahead of time. Other thing is that, you know, he said that we must go beyond what architects want. Architect had initially planned this building, I'm not sure the slide is there, with all the shear walls going down to the base. There are 3 basements are there. The configuration was like that, and it's on a hill. So, and so much space was lost for parking. So he was very concerned about it, and he called me and said, no, Vasudev, we should not do like that. First of all, building should be open when you enter. You know, it should be open. You should have an open feeling. Then what do you do? How do you go to this one? And he said he shifted all the, you know, the ramps at one corner, and it housed also a cylindrical tank. So, you know, he was always very, very concerned that we should not just accept what he said, but we can suggest to him how we can improve the whole building for the occupants, something like that. And of course, it threw many structural problems, headaches for me. But then this is part of the game, you know. The shear walls have to be supported on the sills, and we did not know. It's the first building I was designing. But then, you know, you follow the load path. It's very simple. You have to transfer both vertical loads and also horizontal loads, as you can see here. And later on we came to know that this is being called strut and tie model. But you were already there. I think it is just if you understand the load path, I think it tells you everything. Petit hall, I will not say much about it, but I must tell you why we did this. You know, it's simply because Shirish, we are all concerned about amount of concrete and steel you consume. With precasting, what happens is that we have very cheap labor. So we can make special forms, we can make slabs which are voided, you know, because there are no beams in between. Spanning something like 16 feet, the overall depth was 8 inches. Concrete was much less than what is required. Same thing for the wall panels and so on. Now, what happened was, of course, he and Shirish went ahead to see various countries, including London, and we decided, we knew what we had to do, but we were not very sure because our building is going to be 24 storied, far ahead of times at that time. So we made a mock-up at Andheri using the same mold, same technology, whatever it is, and see, we load tested it, you know, and that was something. In fact, I was not part of this project. He and Srinivas Sachar were the people who were working day and night after this. So what we did is that subjected this building to a load of upper stories, 20 upper stories, and also horizontal load by vertical pre-stressing cables. And we invited IIT to take measurements. And let us come to some conclusion. And I think it behaved very well. And some of us said, well, such a poor quality construction, if this could survive, there should be no problem. So then, you know, some of the details what we did at that time were very delicate. I mean, you know, what happened was when you got very thin elements, even during handling they could break. So we revised all those details, and we did this Andheri housing in 1972-74. We made with improved joints so there will be no leakages. And there are many innovations in this. I mean, when you design buildings like that, you must design also how it's going to be erected and so on. So this is a typical plan. This is the casting yard. So we have to, you know, it's not for the contractor, we are part of the whole team, we have to design everything. See, now this is a finished box unit, you know, with WC pan, everything in the loft and everything. It had just to be implanted, that's all. No joints in that. There's some other details, improved details, I'm going to that. So what we did is that, you know, Shirish was involved with Sitco. So we shared all the information we had, all our tracings were given to them so that they can make use of it in whatever way. So we could produce houses which consume less cement and steel. Basically, that was the objective because, you know, after the war, especially Eastern Europe, were very short of materials. So they would not give permission to any building if you consume more than so much of concrete and steel. Very simple. So anyway, this is one of those buildings we did with a Goliath crane. It hasn't taken off for various reasons because we're still very lethargic. This is a building with Charles Correa, was the architect, and yes, I mean this is one of the first buildings where you can see the lift shaft was going ahead of the rest of the building to cut time and so on. It's very simple building, simple framing. As it happened, whatever architect wanted, it fitted well with the structural aspects of it and so on. Yeah, this is the finished building, which is a still iconic structure. Now, concept is that people would live in a bungalow, something like that. You have 2 levels. You know, when we started with the project, it had only 2 types of flats. But knowing the architects, finally you can see some people wanted. They liked it so much, they wanted 3 floors, 4 floors. It was crazy. So, but it is still okay. You are able to balance the loads. This is a project which actually Shirish is very fond of, and both of us worked on it. I would like to share some moments on this. You know, see, there was an FIP commission who was visiting India at that time. They wanted to see what is happening in precasting or pre-stressing in India. So they went to this site. This is the finished building, and they were so impressed that Shirish was invited to FIP Congress in London in 1978 to make a presentation. So, and yeah, this is where Shirish comes and we walk together. Initially this was a kind of planning. I won't go into the details. There are EOT cranes running in north-south direction. In the end, they're coming in other direction, east-west. So Shirish said that actually they didn't want 20 meter by 20 meter span. They want only 20 meter by 10 meter. Then Shirish said, what happens when you want to extend? Have you thought of future extensions? No, they didn't think of future extensions. So they said, okay, when you want to extend, what will you do? So we will design a building for you such a way that same panels can be reused again, lifted and reused. So that's how we came with 20 by 20 meter span. In fact, one bay has been extended since then. So it's amazingly simple, 20 meter span, 2.5 meter pretension hypershells, pre-stressed bowstring girders, roof trusses, gantry girders. Everything was very simple, everything was 50 millimeter thick. So you can see some of the slides of that. Sorry. It's all off-site precasting. You can see the shells coming here. And you see the crane girders, they had some crane girders at the top, they're going full span, they're semi-portal crane girders. So instead of having 2 crane girders, you had just 1 crane girder which carried the, on the upper flange, the main cranes, and on the lower flange, semi-portal crane. See, this is the view in construction, and there's very little concrete in this. For covering an area of 20 meters by 20 meters, there is just 9.3 centimeters of concrete. That is the advantage of precasting. And we did everything. We didn't choose expensive molds. We used masonry molds for the first time. They were steam cured. Construction in progress. Well, this is a very interesting part I would like to share, how Shirish thinks differently. So, okay, I designed this wall panel, everything is very slender, only 50 millimeter thick. Of course, there's channel shaped sections because they have to span vertically for the wind and so on. Okay, now you come to beer bottles, and that's what Shirish, we're thinking of what kind of permanent finish, because such tall, high buildings, it costs a lot of money to paint. And I was thinking of something like Vitrum tiles, something like that. Shirish came with this idea of beer bottles, I think, which he had also used in Petit Hall. I'll tell you afterwards why it was broken. So why beer bottles? It so turned out that it was much cheaper than any of the other finishes. Point number 1. Point number two, it's a very glossy surface. It will never correct moss. Thirdly, this fluted surface makes water just run down. It won't go sideways into the open joints. And of course, we had a contractor, he had already devised how to split a bottle into two and so on. And the problem was that, in fact, our client did not like this at all. What will happen to the corporate image? But the cost of beer bottles went up, which is also a fact. But see now, okay, what I want to see in the side, we had these open joints, okay. Now, what happens for the rain which could come through that? So he had these serrations, so we should break the thing and water would come down straight away without any problems. See, this is water, groove surface on the side, and everything is proper and no water would go into the building. So this is, 2020. You can see the workshop still. It has never been, painted or anything like that. So, I mean, when you do good quality precast construction, it is maintenance free. Yeah, okay. Now I'll come to what are the lessons we learned. This is something about Shirish. So we keep on learning lessons and how to improve. First was the building had fixed louvers which are 3.6 meter high. Provides excellent ventilation. In fact, one thing I must tell you is the Factory Act requires that nothing should be below plinth level of 1 meter, something like that. Okay. So the building is 60 meter wide and 120 meter long. And according to factory inspector, forced ventilation is required. And factory inspector was invited to measure the number of air changes. Number of air changes was found to be well above the minimum required. So one problem solved. The other problem is during winters, inside the factory, it became very uncomfortable workers. So they had to mask louvers about 2 meter high, which is also not a good thing. The joints between the panels were open. The wind-driven water, rainwater could not enter the building because of inclined serrations inside. But during rains accompanied by winds, wind-driven rainwater did enter the building despite an overlap of almost 60 degrees. And other thing we learned, of course, is that during winter, sunlight did enter through the north light. So north light is not a correct concept. So this is what he started saying. First of all, you must have ventilation from the ground level, as you can see below. And you should not have something like that because that's the airflow. So there is stagnant air here. And this is what we should be doing. Asbestos sheets had the standard skylights, but the problem was it had only wired glass. So there was always a patch of light. Nobody could work there. So this is very simple. What he suggested is that you got a wired glass and you paste on it molded glass. That's all. And you get excellent lighting. And in fact, you get much better lighting on the vertical faces, which is very important for people who are fabricating things. So this is what led to, first of all, in the hydraulic shop, controlled ventilation by rotating louvers. These are again in precast concrete. You can completely control the. And you also started strip lighting. And this we have been using since then extensively for many other factories, not just here. This is for Mahindra's. And you can see some people, they want a window inside and so on, no problem at all. In fact, Kapurthala, because it gets very hot there, they wanted some glass panels, but where, these louvers were there, we had this khas, and rainwater pipes which would drip down and make it very cool. So you see, he was very concerned. He's saying, look, it's not enough to design good structures, but it must be comfortable for people inside. Okay. Well, this is a very interesting project. Pilu Modi was the architect, and it's quite hilarious how things happen. They went to the site and they saw the whole thing, it was open site. And Pilu Modi just made a sketch and said, this is what your building should look like, you know. And that's it. Then they came to me and they said, showed me. I said, I was scared. I said, Shirish, what is all this, you know, all these cantilevers? He said, no. I said, I think we can ask for some corner columns, right? Vasudev, that's for next project, not for this project. Okay. So then Pilu Modi said it should not be for 2 floors, it should be actually for 4 floors. They were simply aghast because we don't even need that much space. We'll never require so much space. Sure enough, they were short of space and the building was extended. So, and there's so many things we learned from this building. Well, you see, this is the complication of the building. You know, it's 4 squares overlapping each other. It's an office space which is completely open, and only the, you know, central core was going down and structural mullions all around. They're all structural. So, then we had a lot of discussion about how the cable should be there. Shirish used to participate. Sometimes he used to argue, we used to quarrel, but we used to agree finally. We came on this, and everything had to be precast because that was the strength of ECC. Precast waffle fans, precast mullions, except the bottom, which is in reinforced concrete. Sorry. So you see, everything was precast, shajas, and you know. So you can't do this in situ. You save concrete basically. This is what it looks like inside. This is when it was extended finally to 4 stories. That's what Pilu wanted. And yeah, this has won some awards and so on. And you see, Shirish has always way of doing things different from sometimes what even the clients want, you know. There are 2 hangars in Bangalore. This is design and construct tender. Now, I'll just tell you something more about this. See, the client required a north light roof of 45 meters wide and 90 meters long. And I did work on this solution because if you don't give this, clients will simply reject that this is not acceptable. So this is one alternative, which I liked, I must confess to you. This is the second alternative which Shirish suggested. Very neat, no ties. It's a folded plate spanning 45 meters and strip lighting. You know, that's great because you don't require any maintenance, you know. So, but how do you construct this? Well, this is what it looked like interior. It's very clean. It's like a folded plate in steel basically. Sorry. So this is the detail. You see, this is what I did. This is a 3-pinned arch. It's very economical in terms of steel consumption. And this is how the whole thing was lifted. My colleague Srinivasachar, he is not here, but he is the person again with Shirish, and we worked together and how to lift up this whole roof from bottom to about 12-meter height. Why do it like that? Because you do everything properly. You did in fact the wiring also. You paint it, you inspect it, everything is done. So nothing is to be done when you go up to the roof. This is the first roof being lifted. I must tell you there were many problems. I won't go into that. Problems of tolerances and so on. But where Shirish comes in is that he says, look Vasudev, suppose something gets stuck. What do? You can't bring down the whole thing. So you must have an arrangement of able to replace the jack with a new one. And it did happen, you know. So that is his foresight. This is up, and there are 2 roofs, and first roof we had so many problems. Second roof, the contractor became very confident. They lifted everything in one piece with jacks on, you know what jacks? 25-ton truck jacks. You know, Dr. Patel was a client. He went to Lahore. Shirish said, no, Nori, I can get this 25-ton truck jacks easily available. So whole design was tailored to these jacks because we must know what contractors can get easily. No point suggesting something very fancy like pre-stressing and so on. Go ahead with that. And The second hanger, the subcontractor is very confident. Aram say he lifted the whole thing, no problem at all. Well, this is something we did at BHEL Bowl Mill, part of the design. Again, it's something very simple again. I won't go into the details. It's a funicular roof with 30 and 24 meter spans with various crane girders and various moon heights and all that. In fact, the client here also wanted a north light roof. And I don't know if he gave a solution or not, but north light roof would have been very messy because first of all there are gutters, so many gutters. Then you have to maintain the roof. It's never clean. So we gave this as an alternative which is much cheaper. And they came and visited some of the things we had done in Nashik and so on. So you can see here the funicular trusses. Why they are called funicular? Because it's like an arch which is cut into half and you join something like that. And columns, that's the advantage of precasting. You can make trussed columns which consume much less concrete. And that I'll show you. You see, it's very simple. No sophisticated formwork. You've got the pre-stressing cables, reinforcement, everything is laid. Very simple to construct. You see, some columns have been erected, some are on the ground and so on. You can see the size of the columns. And it had to accommodate all kinds of requirements of different spans. They wanted the same flexibility of a steel structure, something like that. Again, very little concrete. This inside view. I didn't tell you that there are no internal gutters, by the way. But Shirish made a very big point that look, when you design the factory, and if you've got downtakes going underneath, then they have to cross each other. They may cut some cables. So what do? So this entire huge area, 160 by something, no internal gutters. All the rainwater would come, and same 50 millimeter thick sections in a gutter shape. This is the integral coach factory. I think Jagdish really was there, and it's a very huge project, and it had to be done in a very short time. And sorry, you see, it had to be something to be constructed very fast. Again, we use it concept of folded plate roofs with very little steel. In fact, if I remember, for the first time, we used purlin sections with I think 35 millimeter by 35 millimeter, something like that, because span was not much, and the rakers out of sections and so on. And it was very simple. It was load tester also. And some they wanted use precast columns extensively, but sometimes they wanted steel columns and so on. No problem. This is an interesting example of why it is important for us to know what costs less in our country. Basically, original design, it was dry dock. It was a design in structural steel. Everything was in structural steel, roof and everything, and 6 meter span and so on. Nothing wrong with the design. Probably that would be the best thing what you could do in UK, because the consultant is from UK. And the problem is that AFCONs were the contractors for whom we give an alternative design, and the dry dock was already, diaphragm wall already constructed, and the time was short. Now, if you have steel columns, you can't do the capping beam or anything like that till you have the bolts. And bolts cannot come unless you have fabricated the sections. And those sections were not self-supporting. That's why when I came across an idea of columns, which are actually box columns, I'll show you. Huh? No, the construction. Next slide, I think somehow. Oh. It says battery is running low. What do you do?
You can switch from gray. Sorry.
Sorry. I think it's another way of telling me the time is up, the battery is low. My battery is still okay. Okay? I can do it here. I can do it here, no? No? Yeah, okay. I can work from here or there on. So you see, these are the columns, which are self-supporting. It has nothing to do with the diaphragm wall. They are hollow columns. People can go up the staircase and so on. And you see, there's a roof which is designed for very heavy cyclonic wind and so on. Again, kind of a funicular shape, simply because that's most efficient in this kind of conditions, with very heavy uplift, upward and downward, where triangular purlins and so on, According to the contractor, they saved about 20% of the cost, lower than the cost of structural steel, which was big. And as a result, we came in, the clients were quite happy with us. We also designed these dog gates. Dog gates again is a different cup of problem, and it's very. I think that is the beauty of civil engineering, is that it's not just structure. The dog gates, there are IRS specifications. They must float like a ship. They have to satisfy that, and they have to be sunk. During sinking operations, we have to give the whole manual. What happens to the free surface effect and so on. Okay. Konkan Railway, we started with something very small. The chief engineer there, he knew me, he called me and he said, look, we're not happy with our standard designs with massive piers, abutments and slabs and all that. So I said, no, we can design something for you, but our fees will be 3%. He says, no problem, but if you can show me saving, I'll give you 3%. No problem. So we gave a very simple solution. It's kind of a funicular shape, and you got that. And then if you calculate the concrete, it is much less than what you would do in a traditional design. Well, this is what ultimately led to Panvel Nadi Viaduct, which is again first application of incremental launching. You can see here the tapered piers, because they have to be hollow, because in earthquake region, so you must save the weight of the structure, and the wall thickness is just 325 millimeters, enough for your slip forming jacks to go up, And yeah, this is the finished bridge. Sorry. Yeah, and one thing very important that we learned actually in this project. One thing I did, I must say that whatever information we had about incremental launching, we were about 20 years behind Europe already, and we can't necessarily follow whatever they're doing. There is not much information about that naturally, but so what we did, I would say, is share the information, whatever I have about incremental launching, to the client engineers, to the contractors engineers. I said we are all together in this, and you please ask questions. We learn from each other. So in fact, we suggested this push launching, launching using standard pre-stressing cables. Otherwise, they normally use special jacks made for this and so on. Sorry. Okay. Sorry. Yeah. Yeah. So you can see the incremental launching in progress now. So here, we have to design everything. The launching nose, the connection. In fact, our design was proof checked by a German consultant. We have no issue with that. When I was told that, I have no issue. You please appoint somebody, but somebody who knows about the problem of this kind of construction. Not any other person, because he will not. And one of the things they said is they didn't like the connection which had between the nose and the concrete. And he suggested use of precision cables. So I had no issue with that. If it's a better detail, we follow that. I have absolutely no issue with that. So, I think it's going upside down. Yeah, this is the finished structure. Oh, okay. Now, this led us to actually design of many bridges, which were very unusual in the sense that, they had very deep embankments of about 22-meter height and so on. And railways had already the standard design, which is 3 spans of 20 meters, something like that, with circular columns and so on, piers. But the problem was that they can't do anything till the embankments were done. After the embankments were done, no contractor would just come and make the whole thing viable by erecting just 3 spans. It's too expensive. So when we were approached, we had altogether different thinking on that. We just do something very simple, which is piers which are very slender, and cast in situ reinforced concrete slab. They are much cheaper and no maintenance. You can see this. This is a very unusual flyover and happened in Goa. Again, all continuous structures. The entire bridge is on curves. I'll tell you why. See, what happened was, Goa is already very congested, and they had only way to approach was over the road, and that would eat away into the, all the shops and so on. They objected. Then they said, no, we cannot accept this because we'll lose all our living. So that's when we came, and at that time the chief engineer said, look, you can do whatever you want, but it has to be within the railway line. You see, that's the red line is the boundary. So as a result, every span of this bridge is continuous and on curves, which means we have to develop everything, its alignment, and you see here, this is what happened. This is a view today. And then, Konkan Railway approached us for designing many bridges in Jharkhand, at far off places. And again, we did all these bridges. There are no bearings, they're continuous. They're very simple to cast. We couldn't choose pre-tension because you have to transport these girders from one side. They're simple rectangular sections, post-tension, with cast in situ slab. No diaphragms. See, this is the bridge under construction. Yeah. Now this is what we did for Delhi Metro. Again, sometimes opportunities comes for thinking totally differently. They had made an estimate of this 6.5 kilometer viaduct in Delhi, and I was called and they said, look, want you to do something different. I mean, basically want to do something economical. And we were looking at it and so on. They were always under pressure. And they were not, in fact, initially I was thinking of in situ solutions and they didn't like it. And time was running out. And I told Shirish, look, we can't do this in this kind of time, but we'll give some simply supported solution and all that. He said, no, you must do what you think is right. So back to square one. So that's how this solution came up. Full span precasting and no bearings. You can see here. Sorry. And post tension for continuity. And there are all kinds of problems were there. There is, in fact, column drain, which is a pretty nasty problem because, our columns are very slender but suddenly we can't take that kind of height. So we had to do something. The whole design would change otherwise. And there was already existing road bridge underneath. So there are the station buildings. Okay. This is a flyover which we did recently. It's a 4-lane flyover with metro rail going above. And the challenge given to us is that, look, that this is our standard design, but you must design in such a way that same erection machine should be able to erect the 4-lane highway also. So we came up with the solution of a segmental box which had similar weight and same machine could be used to erect both this also. You can see this erection going on of the spine girders and upper above. These are some of the standard sections and so on. I'll skip that. So, see, this is what happens when you work on projects like this. It's really a challenge, but we have to answer that. Okay, I'm almost at the end now. This is, of course, bridge. What happened actually was, they wanted a foot-over bridge, and my colleague worked out something very simple, 2 spans of 30 meters, something like that, to the central pier. Shirish was shocked. He said, "Have you people gone mad? Have you seen this?" I said, "Yes." Then I said, no. You should never do something like that. You must think of future. You should span across. Okay. Then he said that you must do it in such a way, it's very complicated element as you can see, comfort of the people. They should be made to walk as less as possible. So, and there's inclined arches, and the same section, Shirish had this fascination for using the same section everywhere and so on. So, it was not a easy bridge to construct, but there it is for you. And and Shirish always said that when you design anything that for which there is no architect, but you must think and do something to make it look different. Sometimes it may not make any sense structurally, like that. You see the triangular opening, there is no logic. But one person looks at it, starts thinking, said, why? He likes it. So, this is again a footbridge there. Now, why should one do a bridge something like this? One could do a simple staircase. No, because this will catch the eye of a person. He will imagine, he will see something different. Well, yeah, the layout of industrial structures are governed by manufacturing process. The structural framing of bridges is closely influenced by the conditions, construction methods, and many other factors. So, engineers must pay attention to the aesthetics of such structures since architects are seldom involved. So, our practice has been to appoint a consulting architect and incorporate the suggestion for enhancing the aesthetics. So, elegance, aesthetics, clarity in the structural form, minimal material consumption, constructability, most importantly, no computer software at the time of initial design. And constructions require teamwork. Designers must understand construction, contractors must understand design. Construction requires overlapping responsibilities, not clear divisions. At a workshop conducted by Professor Ravi Sinha, he started with this very profound question. He says, has the civil engineering community become a dinosaur? Does civil engineering community have any concerns of public welfare? This is a question he raised. Of course, I won't go into the discussion what went afterwards. That was pretty hilarious. So, as an expression of gratitude, we are grateful to all those who have been associated with the SPACPL without whose support our assignments would never have seen the light of the day. This is the last slide. I must say something on the quality. There's a misconception. When you talk of quality, no, we can't afford quality. They say, quality, what is quality? You can't measure the quality, And quality is luxury, So quality is intangible, therefore not measurable. Cost of quality is expense of doing things wrong. Very simple. Just the last slide. So, we thank you sincerely for giving us an opportunity to share our nights of the legacy of Shirish Patel, whom of course I miss very dearly. Thank you.
Thank you, Dr. Nori. I think I would like to add one more thing, that integral bridges designed by SPA, I think he has a record of some 25 bridges. I forced him to give me the calculations, and we found that I work in carbon reduction, so I found that it has the lowest embodied carbon. So it is not only lowest cost but lowest embodied carbon and lowest maintenance. So I don't know why the art of integral bridges is not being followed. No question.
I'll answer your question why. Because it is more difficult to design such bridges.
Okay.
It requires more engineering effort. And if you look at the codes will list some, our codes are very poor. See, concrete has got a great thermal resistivity. It doesn't expand in concrete like steel. And we have to make use of that. And it's very easy, it's not difficult. You take measurements of the existing bridges which are there, even in Mumbai, 12 meter span. You go and measure the temperature. They just expand and contract for the fun of it. Concrete has got a very high thermal resistivity, and our people will not accept that. In fact, when we did Panval Nadi, there's a 400 meter long bridge. Okay, now, if you calculate as per the code, it will expand by 120 millimeters or 250 millimeters. I don't remember the value. And we designed those very complicated joints because railways would not accept otherwise. But they forget it's a ballasted track, first of all. It's very well protected. So all that you have to do, please take some measurements for the period of time. Nobody wants to do it. Nobody wants to take any trouble of even take a tape. You don't require sophisticated instrument. Nobody wants to do it. And in a country like New Zealand, I'm sorry, I'm overstepping on this because it's a technical issue. They have appointed a consulting firm to study the performance of bridges before, earlier bridges with masonry bridges, customs and so on, and the later bridges. They find that all the earlier bridges, they withstood earthquakes very well. The recent bridges with bearings, they have been falling apart. So they have now made a code of practice guidelines which have circulated to many people, and they say the importance of doing this kind of construction, taking measurements, is a must. Thank you.
Anyway, thanks a lot. Thank you very much. Now it's your.
Thank you so much, sir. It was really amazing to be an audience for you today.